Okay, so today we are solving other types of equations. Yeah. What we were doing yesterday, but today we're doing it with radicals and exponents. So whenever I have a square root in an equation or a cube root, I want to isolate the radical on one side and put all of my other terms on the other side. So the first thing I want to do in number 1 is add that x over to the other side. So then I have the square root of 2x plus 7 equals x plus 2. Okay. Then what I want to do is I want to get rid of this radical, so I'm going to square both sides. So then on my left side, that just leaves me with 2x plus 7, because I get rid of the square root, because that cancels out with my exponent. And then on this one, remember it's really x plus 2 times x plus 2. So if I distribute, I get x squared plus 2x plus 2x plus 4. Okay, then what do you guys want me to do next? Okay, so I still have 2x plus 7 on the left, and then on the right side I have x squared plus 4x plus 4. Thank you. Okay, now what do you guys want me to do? Okay, so I'm going to subtract 2x on both sides, and then I'm also going to subtract 7. So that gets me 0 equals x squared plus 2x minus 3. Then what do I want to do next? Factor it. So what multiplies to negative 3 and adds to positive 2? Then I want to take each of those and set them equal to 0. So on the first one I subtract 3, and I get x equals negative 3. On the second one I add 1, and I get x equals 1. Whenever I'm working with radicals, sometimes I create extraneous solutions. I need to check to make sure that these two values both work. And I always do this whenever I have a radical in the problem. So let's check the negative 3 first. Whenever I'm checking, I only want to change one side of the equation. So I want to simplify the left here. I have 2 times negative 3 is negative 6. and I'm adding the 7. Negative 3 is the same as adding 3. And my final answer should equal 2. What is negative 6 plus 7? Okay. When the square root is already printed on the paper for me, I assume it's always positive. So the square root of 1 is going to be positive 1. So does 1 plus 3 equal 2? No. So this one doesn't work. And then I need to check to make sure that 1 works, otherwise, otherwise I could have no solution. I was like, what am I trying to say here? Okay. 2 times 1 is 2. And then 2 plus 7 is 9. And the square root of 9 is 3. Does 3 minus 1 equal 2? Yes. So x equals 1 is my only solution here. Questions on number 1? Okay, so sometimes it gives me 2 radicals. What I want to do when it gives me 2 radicals is move one of them over to the other side, square it, and then go back and square a second time once I isolate the second radical. So what I want to do here is I want to add the square root of x plus 4 to both sides. So I get the square root of 2x plus 6 all alone on one side, and then 1 plus the square root of x plus 4. Then I want to go ahead and square both sides. So on my left side, this just gets rid of the radical. I said it gets rid of the radical, and then I wrote it. So I have just 2x plus 6 on the left. And then on the right side, I'm really multiplying 1 plus the square root of x plus 4 times 1 plus the square root of x plus 4. So if I distribute, I have 1 times 1 is 1. 1 times the square root of x plus 4 is the square root of x plus 4. The square root of x plus 4 times 1 is the square root of x plus 4. And then the square root of x plus 4 times the square root of x plus 4 is just x plus 4, because it gets rid of the radical. Okay, then I want to go ahead and combine like terms. So I have 2 square root of x plus 4, because I have 2 radicals, and then I have this x, and then I had a 4 and a 1, which add to 5. Okay, then I want to get all of my all of my terms that aren't radicals on the other side. So I'm going to subtract x from both sides and subtract 5 from both sides. So I'm trying to isolate the radical. Okay, then I get x plus 1 on the left equals 2 square root of x plus 4. So what I can do here is, because I just have a number on the outside, I can square both sides to get rid of that radical. Okay, so x plus 1 squared is going to give me x squared plus x plus 1. And then on the right side, what I do is I take 2 squared, which is 4, and then the stuff in the radical just stays and loses the radical. But I have x plus 4 multiplied by that 4 on the outside now. Then I want to combine like terms on the left side, so I have x squared plus 2x plus 1. And then on the right side I want to distribute, so I'm going to have 4x plus 16. Okay. Then I want to move everything over to the other side of the equation, so I'm going to subtract 4x on both sides and subtract 16 on both sides. I end up with x squared minus 2x minus 15 equals 0. Okay. What multiplies to negative 15 and adds to negative 2? So then I want to take each of those factors and set them equal to 0. Which gets me x equals 5 and x equals negative 3. And then again, I need to check my answers. So on my first radical, 2 times 5 is 10. On my second one, 5 plus 4 is 9. 10 plus 6 is 16. The square root of 9 is 3. Then I have the square root of 16 is 4. Does 4 minus 3 equal 1? So x equals 5 is an answer. And then I still want to check negative 3 because sometimes both answers will work. So on my first radical, 2 times negative 3 is negative 6, and then I'm still adding to that 6. On the second radical, I have negative 3 plus 4, which gives me 1. So then I want to simplify that first radical, which gives me 0. The second radical, the square root of 1 is 1. So then square root of 0 is 0. Does 0 minus 1 equal 1? No. So that's not a solution, just the x equals 5. Okay. So on number 5, this one has an exponent. The way I get rid of these fractional exponents is I raise it to the reciprocal exponent. So here I'm going to raise both sides to the 3 halves because I just flipped the fraction. So on my left side, my exponents cancel out, and I just have x plus 1. And then on the right side, I can type this into the calculator. So I can do 4, and then exponent button. If I'm on a newer calculator, I can type 3 divided by 2 as is. If I'm on an older calculator, I want to put the 3 halves in parentheses. And then I just press enter, and it gives me the new value, which is 8. Good. To solve for x, I just want to isolate it. I'm going to subtract 1 on both sides. I get x equals 7. Just like with the radicals, I want to go ahead and check my work. Because remember, exponents with fractions are like radicals. So then 7 plus 1 is 8. So I want to raise 8 to the 2/3 power to check. So I can go 8 and then exponent 2 divided by 3, which gives me 4. So this worked. 7 is my answer.